Hi, this is my night kit KG696 RF signal generator. I don't remember exactly when I built this, but pretty sure I was a teenager at the time. So that would be the late 60s. I left for college shortly after that, and it just sat in my parents' basement. Many years later, I rescued it and stored it in my attic along with some old radios that I'd like to work on. So I need to revive this thing first. Looks like the dial still works anyway, so that's a start. It runs on a battery, I'm not even sure what kind. This must be the battery compartment. I'm afraid to look what's inside. This hasn't been opened in 50 years. Well, that's good. The battery is missing. Here's the connector. Looks like the negative lead broke off. There it is hanging inside the case. So probably a 9-volt battery. Let's open the case and see what's up. Oh, nice. Now the positive connection from the battery just broke off. But I think it was connected to one side of the power switch. And the other side is connected to that red wire that's grounded to the phase plate. And then that's connected to what looks like a ground bus on the circuit board. And the positive side of that electrolytic capacitor is on the same bus. So it looks like maybe it's got a positive ground. Let's just see whether I can find any information for it online. Well, I can't find any owner's manual, but I did find this product review in a ham radio magazine. And amazingly, it includes a complete circuit diagram. You can see it is a positive grounded circuit, and the positive from the battery goes directly to the power switch and then to ground. It's got just 2 PNP transistors, one for the audio oscillator and one for the RF oscillator. They're germanium, not silicon, so that's a little worrisome. But at least I know how to reconnect the battery. Okay, I've got the battery terminal reconnected. I've reconnected the power wires. And looking at this, it doesn't look like there's too much that can go bad over time. There's one electrolytic that seems to be directly across the power line. So the worst that's going to do is short out the power. So I don't feel that's going to hurt anything. So I think I'll just put this back together and see if I can get a signal out of it. Okay, I've got a radio, and I know it works on the AM broadcast band.
Monday through Sunday. Save big on top salad.
Let's try 1400. Kind of wonder if this antenna connects to anything on AM. And I don't hear anything at 1400. Maybe I'll try a different setup for the antenna here. Okay, so I've made a little loop out of a clip lead here. Tried to use that as a broadcast antenna. Let's see what that does. That's a little better. But the frequency is certainly way off. It's around 1,000. This is around 1,400. So now I got this on the C band, which starts at 1.6 megacycles, and is picking it up in just about the right place. If I go back to 1.6, on here, 1.6 on here, matches just about perfectly. Try going back to the broadcast band on here. Which goes up to 1,600. Oh, I'm just barely getting a little bit here. Seems to be picking it up the whole way across the band. And not really tuning. Let's switch to band A. Now I'm tuned to 460, so I assume that's some kind of interference with the IF. Assuming that's at 455. But why it can't pick that up at the top of the band, 550. Well, there it is. But it doesn't seem to work as well when I turn it up to the broadcast band. Now it should come out down here. There's a faint signal, but it doesn't appear to tune. Now this, okay, so this is 700. It's about 600 on here. Now I'm at 1,000. This is only on 700. Okay, so pretty crazy. Now I'm at 1,500. This is around 800. It's almost like it's a double the frequency, and yet I can gradually tune this back, and it gradually moves across the AM band. I think maybe what I should do is take an oscilloscope to this and see if I can actually see the signal. Try to figure out what's going on here. Okay, but first, this radio does have a couple of short wave bands. So let's see if we can pick up anything on those. And I think I'll assume that that's going to use the whip antenna. But anyway, let's just turn it on here. And I've put a little arrow on the band switch so I know what band I'm on. Turn on the radio here. So here we go to, there's that's AM, and that should be shortwave 1. So let's turn that down to, I'm picking up something there. Huh. That's actually on band A, 550 kilohertz. So I assume that's some sort of multiple. Let's put it back up on the proper band. And that would be band C. And we'll turn it down to, let's try this 3.2 megahertz. And actually there it is. So this is reading actually 2.9 megahertz. So actually pretty close. So there's another band here, starts at 4.5, goes all the way up to 13. Okay, so that's band D. Let's take that down to, say, 5. We should be able to tune in 5 here. There it is. The frequency of the modulation seems to have changed. Let's go up to the top of this band, which is about 7. And there we are. So 7 megahertz. And then there's a second shortwave band, starts at about 9, goes up to 22. Let's go down to, switch the band here. Down to 9.2. And okay, so that's up here on the same band. There it is. It's quite a bit fainter. This is actually about 9.1. This is 9.2, so pretty close. And finally, let's turn this all the way up to 20 megahertz. And see if we can get anything. That's band E. And there it is. That's about 19 and a half on here, 20 on here. Pretty close. And really nothing else anywhere on the spectrum. So actually the short wave bands on here seem to be working pretty good. And it's just the broadcast band that seems to be way off. So I think I'll again check the broadcast band on the oscilloscope and see if that agrees with what we're getting on the radio. Okay, so we're connected to the oscilloscope here. And we're on AC coupled, 2 milliseconds per division. we're on the broadcast band here. Let's just switch it on. And so we've got a signal. There we go. Nice modulation. So let's go to this band C, where we know we got the right frequency according to the radio, and we'll adjust this to 1.6 megacycles. And if we put this on 1 microsecond per division, let's turn the modulation off. Get a cleaner signal here. So that means the whole scan is 10 microseconds. So we should get 16 waves across the screen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, well, 17. So that's pretty close. Let's go down to the A band. And we'll adjust this to the bottom, which is 400. So we should get just 4 cycles here. 1, 2, 3, almost 4. So that's pretty close too. So let's go to the broadcast band, which is one that seemed to be way off. And that's band B. So now we're on 550. So this should be 5.5 cycles. 1, 2, 3, 4. And it's about 5 cycles. So a little bit low. Let's go up to 700. So that's 1, 2, 3, 4, 5.5. So we're starting to get too low, just as we did with the radio. Let's go up to 1,000, which should be 10 cycles. 1, 2, 3, 4, 5, 6. Less than 7. And finally, go all the way up to the end here, which is should again be 1.6 megacycles. That should be 16 cycles across the screen. 1, 2, 3, 4, 5, 6, 7, 8, 9, about 9.5. So again, pretty much agrees with the radio, and this broadcast scale seems to be way off. So this is a 20 megahertz scope. Let's just see if we can get a signal at 20 megahertz. That's the E band. Clearly a weaker signal here. So that's half a microsecond per division. Which is as fast as this scope will go. So that should be about 10 cycles per small division. 1, 2, 3, 4, 6, 7, 8, 9, 10. So that's about right. So again, seems to be working fine except for that broadcast band. So let's see what we can do to adjust that. So looking back at the schematic, here's the coil for the A and B bands. That's L1, and it has an adjustable core, and it also has two trimmer capacitors. This trimmer is for band A. It's connected back to the switch and then to ground, and is only engaged when you're on band A. This is the band B trimmer, and it's connected directly to ground. Okay, so we've got it apart again here, and there you can see the coils. There's 4 of them. Obviously the one in the back with the very few turns, that's got to be the band E shortwave coil, and then successively more and more turns, and this one on the top. I can get it to focus here. There you go. You can see that it says L1. So that's got to be the A and B band coil. In other words, the broadcast band coil. And that's what we've got to adjust. And then if we look at the back of the circuit board here, you can see the 5 trimmer capacitors, 1 for each band. We want the one that's connected to the broadcast coil, L1. That's this coil here. You can see there are 3 connections. This connection goes over here to this capacitor, but also up to this capacitor. And at the other end, this capacitor, you can see, is connected to the ground bus, whereas this capacitor, the other end, looks to go back into one of the switch contacts. So this is the one we want, the one to adjust the broadcast band, the one that's connected to ground. Now the way these capacitors work is they're just miniature versions of the tuning capacitor. You've got a top semicircular plate and a bottom semicircular plate, and from this screw they either mesh or don't mesh. And kind of hard to see on the camera here, but it looks like this one is completely meshed, so highest capacitance. And that's good because we know we have to decrease that capacitance and increase the frequency on the broadcast band. So I'm going to try to set that up so we can simultaneously adjust this and then look at the frequency on the oscilloscope. Okay, I think we're all set here. I've got the oscilloscope connected. We're on 1 microsecond per division. This is on the broadcast band. You can see I've got it adjusted to the top of the band, so it's right on 1600. So let's turn it on. Certainly have a signal. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Actually 15 and a half. So now for some reason it's suddenly putting out the right frequency. Let's try going down the band. Go down to 600. And we've got 1, 2, 3, 4, 5. About 5.5 cycles. So that's a little bit low, but actually pretty close. So I wonder if being out of the case is affecting the frequency here. Let's try the other band, band C. which seemed to be correct when it was in the case. And we'll adjust that to, again, 1.6 megacycles. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17. So we're just a little bit high, but not so different from what it was inside the case. So I think what I'll do is put it back in the case and try the broadcast band again. Okay, we're back in the case. Still on the C band at 1.6 megacycles. Let's turn it on. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, exactly as it was outside the case. Let's try the broadcast band. Okay, that's supposed to be 600. Instead, it's more like 1, 2, 3, not even 400. And if we go up to 1600, we're really only at 1, 2, 3, 4, 500. Well, that's pretty odd. Let's look at the A band. Huh. So now there's no difference between the A band and the B band. So it's as though somehow putting it back in the case has shorted something between the A band and the B band. Or I can't imagine what. Let's take it back out. Okay, we're back out of the cabinet. Let's turn it on. And that's still about 500, but now we're on the A band. Switch to the B band. And now we're back to normal operation. So I'm not sure what to do here. It seems there must be something shorting when I put it in the case. So I'm just going to look carefully, see if I can see what's going on there. Okay, so one thing is if you look at where this battery holder is, it looks like it comes pretty close to the circuit board and might conceivably touch that band A capacitor. And if that was shorted to the frame, it would be just like that was always in the circuit. And so it would look like it was on band A when you switch it to band B. So I think what I'll do is I'll put it in the cabinet, but leave the battery holder out, just leave the battery hanging there. See if that works any better. Okay, so again, we're back together. I've left the battery holder out. The battery's just hanging there. I put some tape over so that it can't short against anything itself. And let's give this another try. Now we're getting a normal 1600 kilohertz signal. There's band A, band B, band C. Let's go back to B here. Supposed to be 16, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11,
13, 14, 15, about 15 and a half. So really pretty close. And it seemed to be just a problem with this battery holder. Apparently somehow shorting the band A capacitor to ground, making the unit think it's really on band A. So let's see what we can do about this battery holder. Okay, so what I've done is to try to bend these two brackets toward the back of the unit and also put some electrical tape around the potential contact points. So we'll just put the battery back in. Okay, let's try it. There's the B band. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14, 15 and a half. A band. 1, 2, 3, 4, 5. And that's on 550. So we're back to normal operation. And I might try to readjust these, get a little bit more accurate, but basically it's working pretty well. And I think I can just use it like this, use the oscilloscope to measure the frequency, or else get a frequency counter. Well, on the second thought, I think I'll go ahead and try to align this at least on the broadcast band. So we'll try align it with the oscilloscope, and then we can check that frequencies against known AM stations on the radio here. But let's first align it with the oscilloscope. And I don't have instructions on how to align this, but it's got adjustments in both the coil and a capacitor. So what's normally done is to adjust the coil at the low frequency end and then adjust the capacitor at the high frequency end. So we're on the broadcast band, 600 kilocycles, and we'll just turn it on here with no modulation. Getting a nice signal here. Okay, so that should be exactly 6 cycles between the two ends of the screen. 1, 2, 3, 4, 5. It's about 5.5. So the frequency is too low. Let's try to see if we can turn up a little bit with the coil. So that's a lower frequency. That's about as far as I can turn it. And that's not quite 6 cycles. So let's turn it up to 16 and see what we can do with the capacitor. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So I think that's 16.5 cycles.
try this trimmer. Gonna need a thinner screwdriver here. Okay, there we go. Not sure why it's jumping like that. It feels like it's turning smoothly. Doesn't feel like the screw is jumping. That looks a little closer. So that's pretty much exactly 16 cycles on the screen. Let's go back down to 600. Two, three, four, five. About 5 3/4 cycles. So pretty close, and I think that might be as close as we can get it. Because that's decreasing the frequency. And that's as far as it goes. So I think that's about as close as we're going to get. So let's finally just adjust the A band. And of course what you would use that for is normally IF, probably at 455 kilocycles. So let's turn it to 450, which should be exactly 4.5 cycles. One, two, three, 4.5. Okay, so that seems to be perfect. And I think that's about all I'm going to do as far as the alignment. Again, maybe I'll buy a frequency counter if I actually try to align a radio with this signal generator. Okay, so we're all back together here. I've also cleaned the face a little bit and replaced the missing rubber foot. And just do some final tests here. Let's turn it on. We're still on the A band. Exactly 1, 2, 3, 4.5. It's on 450. That's good. Let's go to the B band. And here we're on 700. 1, 2, 3, 4, 5, 6. That's just about right. Let's try 16. One, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16. Pretty close. So let's just check the output of this signal generator against the frequency of some known stations on the AM band here. So I've got a little radio
Turn on the signal generator here. So just a couple of stations I can get here in the basement. This is 590. And I've just got a wire, not even connected to anything, just clipped close to the radio. That seems to be enough for it to pick up the signal generator. And as we tune near the station, you'll see a heterodyne, which is an audio signal generated by the difference between the actual radio station signal and the signal from the generator. There it is. So at the minimum here, right there, we should be right on the frequency, and this is reading about 620. So it's a little bit off, and again, this is about the closest that I could get using the adjustment in the coil. And just one other station here, which is the sports station 950. There it is.
Had a 32-yard touchdown pass to Greg Ward in the fourth quarter. Phillies dropped 4 in a row. Patriots get to 500, do it in convincing fashion, blowing out the Chargers. Diabetes, high blood pressure.
So that's 950. It's coming in at about 980 on the dial. So again, frequency coming out of this is a little bit low, but again, it's as close as we could get it. So let's just go through some of the other bands here. There's the C band. That's about 3 megacycles. D band. Quite a bit weaker signal, but that's about 9 megacycles. And the E band, that's 20 megacycles. Let's change the time. So it seems to be operating on all bands. Frequencies are pretty close, and I think that's about the best we can do. So pretty good here, this Night KG696. Still working well 50 years later. So thanks for watching.